Welcome everyone to the Geometry Mailbag. Hopefully you're some geometry students that are interested to know how do you do proofs with triangle congruence. So I'm here to tell you, let's go ahead and get started. So we're going to do a couple of these. We'll do as many as we can. I want to keep this under about 10 minutes. So let's see how far we get. Now with these, I already have my two-column proof set up with statements and reasons. And the first thing we're going to do is we're going to look at the problem, obviously. So GK bisects angle JGM, and GJ is congruent to GM. Prove the true triangles are congruent. Okay, so the first thing you always want to do is you want to list your givens. So I'm going to use red, and my statement is GK bisects, oops, I already spelled it wrong. Off to a horrible start. Bisects angle JGM. Okay, and that is given. And then we also have GJ is congruent to GM. And that is given. Now, I want to hold you up right there, because anytime we have two segments, okay, right here, that we list as congruent, what we're going to do is we're going to say, hey, you know what? I know this is a side. Oops, I'm not sure what's happening. This is, give me a second. This is a side. So because I know this is a side, I already have one thing that I need out of three for me to prove that these two triangles are congruent. Okay, so we were either looking for two more sides, an angle, okay, some combination of three letters. The postulates are SSS, SAS, ASA, and AAS. So since we have a side, we know it's any one of these four, so we need more information. Okay, now it always gives you information to build off of it. So in this case, it told us GK bisects JGM. So what does that mean? Well, if it bisects, here's JGM, that angle. Okay, if GK bisects it, means it splits it into two equal angles right here. That's what that means. Bisecting an angle means that it's split into two perfectly. So what we can do is we can say, I'm going to leave this in orange actually. I can say angle, and we have to be specific. We just can't say angle G because it's too vague. We can say angle JGK is congruent to angle, let's go, MGK. Now, what I'm going to do is I'm also going to write a letter A next to it, because now we have an angle. Okay, so now we have an angle. The reason why I write angle is because now I know it's not side, side, side. I have an angle, so we're down to three choices, SAS, ASA, and AAS. Okay? Now, what's the reason? What's the reason we can say those two angles are congruent? It's because that's the definition of an angle bisector. We know that that GK is an angle bisector, so that's the definition of an angle bisector, is it splits it into two congruent angles. Okay, last one, we need to look at the diagram here. We see that we're missing a side. We have a side, an angle. We don't know anything about these two sides, so we're not going to touch those, but we do know something about this side. We know this side is also congruent because they share it. They share that side. So what am I going to write here? Well, first, let me use this green color because we already kind of said that. Okay, so that's green. We're going to say GK is congruent to GK. Make sure you put a line segment on top. Okay, and guess what? That is our third side. Not third side, but it's our second side. It's our third piece of information that we know is congruent. Why is the reason GK is congruent to GK? Is because of the reflexive property. This is going to be a very common one. Reflexive property, oops, don't know how to spell property, of congruence. So this is going to be a popular one that you use. And yeah, so we know it's reflexive. And now we have our third congruent side or angle, and we know that it's going to be SAS. Now, don't just go based on these letters here. Okay, if you just go, oh, the order is SAS, so it's SAS. No, you want to always look at the diagram and infer from the diagram what order it's in. So now we can say, because it's trying to prove, we can prove GJK is congruent to GKM because of side, angle, side. So we're done with the first one. Okay, let's move on to the next one. Okay, we already have our table set up. Whoa, I went a little off here. Something happened. So let's move this guy down. And let's move this guy down. Okay. So AE and BD bisect each other. ACB is congruent to ECD. We need to prove that. Okay, so let's list our givens first. So we're going to say AE and BD bisect each other. And that's a given. Okay. Now, that doesn't give us a side. So what does that mean? If they bisect each other, what does that mean? Well, that means this line, and let's make it a different color, and this line, they bisect each other. So bisect means they meet in the middle. So if it's in the middle, then that means this one is split into two, and that means this one is split into two. So now we can list some more information. We can say that AC is congruent to CE. Why? Why can we say that? Well, that's the definition of a segment bisector. We just did angle bisector, so that's the definition of a segment bisector, is it splits it into two equal halves. So guess what we're going to do? We're going to say the same thing for BC is congruent to DC. Okay, definition of segment, and you see I'm shorthanding here, bisector. Now, what I always like to do, write the letters. We found a side. We wrote side. Okay, here's another side. Now, the last thing is there any other information we can infer? Well, we have here from the diagram that these have intersecting lines. So we can say angle ACB is congruent to angle DCE. Why is that? Well, that's because they are vertical angles. Sorry, I had to go down a little bit. Vertical angles. So what I like to do is I like to write the letter A next to it. Now, this is not SSA because that's not even a congruent postulate. We have to go back to the diagram and say, okay, this was a side, the very next thing was an angle, and the very next thing was a side. So this is side, angle, side. So we can say that true triangles are congruent because we have triangle ACB congruent to triangle ECD, and that's because of side, angle, side. Okay, so now we're done with that one. We have two more that we're going to do here. So we have FG parallel to KL, FG congruent to KL. So we have FG, let's list our givens. So we have, I'm using red. FG parallel to KL, given. FG congruent to KL, that's given. Now, guess what? That's a side. So we can list one side down, but now we need two other congruent statements. So what are they going to be? Well, anytime you have parallel lines, that's a clue. Always build off the clues it gives you. So we're told that FG is parallel to KL. Well, guess what? We have a transversal splitting in between. Anytime you have a transversal through two parallel lines, you're going to create some congruent angles. What are the angles you're going to create? Well, you're going to create some angles here and here congruent to each other. Why? Those are alternate interior angles. Okay, so if you were to look at this like this way, we can clearly see that these are alternate interior angles if these lines are parallel. So we're going to say, you go ahead and use this color. We're going to say angle, be specific, GFK, don't just say angle F, congruent to angle LKF because of alternate interior angles theorem. Guess what? We're going to put the letter A next to it, and we're done with that. We now need one more, and guess what? We have reflexive property. That's always the easiest one to see. So we have FK congruent to FK. This is our third congruent segment that we have. This is reflexive. Sorry about the colors. And now we can say triangle FGK is congruent to triangle KLF. Anytime you have parallel lines, this is a big clue that you are going to have some common angles, some congruent angles with the alternate interior corresponding, etc. Okay, so this is the last one. just about at 10 minutes here, so this will be our last one for sure. We're just going to list the givens first. AB perpendicular to CM, given. We have AB perpendicular to DB, given. Lots of givens here. CM congruent to DB, given. Went lowercase there. Okay, this is a side. Anytime you write a segment that's congruent, okay, write that that's the side. Now, why does it tell us that it's perpendicular? You can just look at the diagram. It kind of basically tells you. But anytime you have perpendicular angles, you know that it creates something that's 90 degrees. So you can say angle MB, MBD is congruent to, no. We're going to say MBD equals 90 degrees. Okay, and we'll say angle AMC equals 90 degrees. And the reason why is perpendicular lines form 90 degree angles. Okay, and that's for both. Lines form 90 degree angles. This one's a little bit like extra how I'm doing it. You don't necessarily need to go that far. I'd be okay with not having that step, but I just want to show if you want to be by the book accurate, this is what you would do. Okay, then you're going to say angle MBD, is congruent to angle AMC. Okay, a couple different reasons you can say. I would just say right angles congruent to right angles. Okay, you could also use like the law of syllogism for that one. So guess what we have? Once we get congruent, we can write A there. So now we have A, and then we have A. And now we're looking, I forgot one given. I didn't even see it. We have M is the midpoint of AB. M is midpoint of AB. Okay, so that's given. We're going to build off of that one now. So we're going to say that AM, segment AM is congruent to MB. And why is that? This is the easiest one. Definition of a midpoint. A definition of midpoint. If it's a midpoint, that means it splits it up into two congruent parts. So that's why we have those. And anytime we write a congruent sign, see, anytime we write a congruent symbol, we know we're going to have another given congruent statement. So we're going to write S there, S, S, and we take a look at the diagram and we have SAS. So we have angle triangle AMC is congruent to MBD. And this was what we wanted to prove, and we can prove it because of side angle side. Hopefully you find this video helpful. Thank you so much for asking in the mailbag. Anytime you have a question, please let me know in the comments, and I'll do a video for you. Until next time, be good, be kind, be true, be nice, and be honest. Thanks for watching.